after you know that it's dry, because you can see that it got lighter, it's as simple as now you have to put the catalyst onto the other one, which is to say you first need to find out which is the conductive side. So we will get our multimeter, and we'll just see which side has a resistance, because it won't pass a current through the side without the conductive coating. So you'll get no response from one side, and you'll get some response from the other, so we know this is the conductive side. So now, my beaker's gone. So make sure to put all fire receptacles into safe places. So now, knowing that this is the conductive side, we're going to make sure to coat that with a layer of soot. So it's as simple as just keeping the glass over the candle for a long amount of time, and you can see, probably after a little while, that when you hold it up to a white surface, you can begin to see a black coating on it. So this will take probably around 5 minutes or so. Really difficult step is putting the two pieces together, which you just have to do by putting the two pieces together and making sure that they are staggered a little bit, so that you can attach the alligator clips to the electrodes. So you can see that they're just probably like 2 through 3 milliliters separated, so that there's an available conductive side for each of the alligator clips. And the important part is also to note, if possible, which you can see based on how you look at it, which side is the carbon coating and which side is the dye covered side, so you can tell which is the positive and negative sides of the electrodes. Is just placing the binder clips onto the sides, making sure that you're not covering up the sides you're going to put the electrodes on. So that's as simple as that. So you're going to attach these here, and then now the only part that we're actually missing is the electrolyte. So what we're going to do is we're going to take from our stack, which will be pre-prepared probably, because you only need about 1 to 2 drops. So rather than make 200 milliliters each time, and you can just by running along either of any of the 4 edges, you can begin to watch that the liquid slowly travels down through capillary action. So you don't need to move the plates back and forth, so that would actually probably force free the titanium dioxide. And if you can tell that it's probably stopped and that you've run out of solution, you can just run it along the side again. And then it's just a waiting game. It'll probably take around 1 minute, 2 minutes. You can slowly begin to see that the dye begins to get darker, and that's just that the solution is over. Best to see if our if our cell is active, if our solar dye worked. And so we're going to attach, it doesn't necessarily matter which end you attach, it'll just be a difference between positive or negative. But you can look in the lab manual to figure out which is which, or try and do the science on your own. So here we see really minute changes based on probably either flickering light or the fact that the light isn't absorbing really well, but if we were to take this outside, we would see that there'd be a large jump in voltage under the direct sunlight. The other option is to put it under the UV lamp and see if there's a bit of a change, because it probably does go into the UV region for absorption. But nonetheless, you can see that we definitely have an active photocell, though poorly active under fluorescent lights.